Hi and welcome to this lesson today on surface area of pyramids and cones. Yep, in the previous lesson we were looking at prisms and cylinders and we're going to keep building on it, and it's only surface area. Later videos in the series look at volume. Alright, but again, today just the surface area. Pyramids and cones. Those of you who have the misfortune to be taught by me will be expected to do this last column of questions if you are in the advanced methods group. G'day, if you're watching in Slant Height, thanks very much for joining me. Really good to see you. And one day soon you'll be able to see me. And that's not necessarily all it's cracked out to be. But hopefully these videos are helping you. Recap always important, all right? In previous videos, we have looked at finding the surface area of prisms, both trapezoidal and triangular. Oh, that sounds very interesting. We have found that there are certain shapes which are more commonly used. Now, I will be very, very clear here. Cylinders come up ever such a lot. Right? We like cylinders, right? Our exam questions like cylinders. Today, we're going to be looking at pyramids and cones. To be able to do that, we still need to have an appreciation of what we did last lesson or last video. And so, if you remember, the surface area of a cylinder was given by 2 pi r squared plus 2 pi r h. How is that true? Well, look, if you remember back, and that's a really bad cylinder, Darren. If we look back, we remember that a cylinder is made up of a circle at the front, a circle at the back, and this curved section here. So the surface area of a circle is pi r squared, there's the front, plus the surface area of the back circle, plus. Now, we realize that this curved surface was actually a rectangle that had the same dimensions as h, but we needed to find that the bit that wrapped around was equal to the circumference of a circle. Now, we know the circumference of a circle is 2 times pi times r with the h. So again, there we go. If we were to write this out properly, there's h and there's 2 pi r. This is the circle that wraps around. We can simplify this to become 2 pi r squared plus 2 pi r h. In my previous lesson, we used this 2 pi r h on its own a lot to help us find that curved surface of lots of different shapes. If you haven't watched it, don't understand it, go and have a watch of the video previously. It's really, really good. Well, in my opinion, it's really good. And then we had the total surface area of a prism. And remember, a prism is any shape that when I put it through a bread slicing machine, will slice that prism into identical pieces. Yeah? So, a loaf of bread, theoretically speaking, taking off the ends, is a prism for all intents and purposes of this. And so, if we wanted to find the surface area of the prism, we find the area of the front and double it, because that gives us the area of the back. Area of the side, double it, because that gives us the area of the front, the two sides. And I'd find the area of the top and double it, and I would end up with the total surface area when I add them all together. So hence, sum, remember, means add together. If we look at the surface area of a pyramid, there are lots and lots of different pyramids. The ones we tend to deal with in mathematics are square-based pyramids and triangular-based pyramids. And again, based, it means the base of the pyramid is square. So if we look at the pyramids in Giza, if we look at the pyramids in all of Egypt and Africa, then we will find out that generally speaking, they are square-based pyramids. They are a square base. Now, I like that, because if they've got a square base, firstly, I'm going to do little lines like that, because if you remember, that tells us that all the sides are the same length. And it tells me that I can find the area of a square really, really quickly. So there we go. I can find the area of the base. Wow, thank you very much. What about the rest of the shapes? Well, what do we notice? There are 4 triangles. And if there are 4 triangles, can we find the area of a triangle? I should go. It's base times height and half it. Thanks very much. But we don't want to be tricked. We'll come back to that in a moment. The other version that we need is this one here, which is a triangular-based prism. Now, again, not used as much in maths unless an examiner is feeling really, really evil. But again, if we know the right dimensions, we can find the area of the base. So we can find the surface area of the base. And the chances are the 3 sides of my triangle, because if it's got a triangular base, it'll only have 3 sides. I would have side 1, I can find, side 2, I can find, and side 3, I can find, and I can add all those together, and yes, I will find the total surface area. So in this situation, I would have taken the 4 triangles, I'd have taken the base, and I would have added them together. That's basically the whole point of this, right? So as I say, in both cases, you find the area of the base, and the area of each side. Now, you need to be really, really careful here, all right? And I've actually fallen over in exam questions myself. Let's get rid of that to make it clearer. There are two things that they can give you for these triangles. One is called the slant height, and one is the side length. Now, the slant height is this, and I'm going to move my computer, and if it makes a sound, my apologies, but I can draw better. The slant height is from this top point here to the center of my circle. So it is this dotted line here. That is my slant height. And you're going to turn around and say, well, why is that important to me? If you were to draw this triangle, and again, sorry if I move my computer around, it makes a noise. If I now draw this triangle, if I told you the base here was 10 centimeters, and I told you the slant height was 50 centimeters, and I draw it front on, then I know that that's 10 centimeters and that's 50 centimeters. And I'm like, yay, I can work out the area of that front like easy, innit, Gov? Because I know the area would be a half times base times height. That slant height is in fact the height of the triangle. And that is great if they give it to me. The side length, wow, that's challenging, because then I end up with that's going to be 10 centimeters. Now, the side height is this line here on the outside of my triangle. If I tell you that's 50 centimeters, we have a bit of an issue. It makes the question so much harder. Why? If I draw this front on now properly, I know this is 10 centimeters. I know this one here is 50 centimeters. Actually, to work out the area of a triangle, I need to know that one. Or to work out the area of a triangle easily, I need to know. If I don't know that one, I have to use Pythagoras Theorem. Do you see where it's going with this? I would know that that was 50. I would know that was 5. Why is it 5? Because this is 10 all the way across. So, and I can only work Pythagoras Theorem on a right angle triangle. I don't know what that height is. So before I go anywhere, I'd have to use Pythagoras Theorem to try and help me find the area of one triangle. So that's just one triangle. Then, once I've done all that hard work, I would, luckily be able to multiply it by 4 to give me the 4 triangles and add to the base. But it's a lot of work. So you want to hope in a question that they actually give you the slant height. As I say here, basics of anything here when you're finding the total surface area is always find the area of the base and always find the area of one triangular face, which you can then multiply by 3 or 4. Now, when I say 3 or 4, remember, 3 if it's a triangular base triangle, and 4 if it's a square base triangle. Because if it's a square base triangle, then it's got 4 sides, hence 4 triangles to make up the rest of the pyramid. If it's a triangular base, it only has 3 sides, or the base only has 3 sides, and hence only needs 3 triangles to make the pyramid. They will always need to give you the dimensions of the base. Generally, it will be a square, hence being called a square-based pyramid. If it's a square, and I do these little marks on there, they only have to give you one measurement, 10 centimeters. I then know that the base would be 10 times 10 or 100 centimeters squared. Likewise, the area of all 4 faces will generally be the same. So you find the area of just one triangle and multiply it by 4 or 3 depending. So here's an example. Find the surface area of the square-based pyramid shown below. This question was taken from a Cambridge Essentials textbook, and because that's what I'm teaching to, it's the easiest to use. No infringement of copyright was intended. Lovely, lovely, lovely. If we look at this question here, and I know these dotted red lines are confusing, but if you notice this dotted line here, this one I'm going over again in green. And I'll rub out the green now so I can show you the dotted line again. What is that? It's my slant height. Whoop, 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 which means if I draw it front on, I now know there's my slant height of 6. I know my total length along there is 4. So I can say the area of one triangle is a half times 6 times 4, which is 12, in this case, meters squared. Don't forget units are squared because it's area. Having found that one triangle, life is really, really good. What do we notice about these little marks? It tells me that it must be square. And so I can work out the area of the base. And this is what's happened with my working out. Here is my base. I knew one side was 4, so I multiplied it by 4 to give me 16 meters squared. Now, in an exam, if you miss units, they actually knock you marks off. So try not to miss the units. Area of a triangle, well, I've already explained where that came from. So that was 12. So the total area of the pyramid, and notice I actually write area of and a little picture of a pyramid. I break it down for the examiner so that they know what I'm working on. That's really, really important, because if you're going to lose marks, the chances are you're going to lose it here. If you've shown some working out, then they can give you marks for your working out. So the area of the pyramid is 16. Where did I get the 16 from? This here is my base. This here is one triangle. Multiply it by 4 for the 4 triangles. Add them together. I get 64 square meters. Love that example. Then we move on to the surface area of a cone. And again, the slant height here is really, really important. Really, really important. Now, this cone has a vertical height given. That's the only thing they give me. And they give me the radius. They do not give me this slant height. And I'll explain what that means in a moment. Now, when that is the case, there is a formula to use for this, and it is horrible. And I can promise you, using this for any exam questions will be, write that in your formula book and make sure that you use it in the right place. But the surface area there would be given by pi times r, brackets r plus the square root of h squared plus r squared. Now, for those of you who are thinking to yourself, hold on, that looks familiar, it is. It's actually Pythagoras Theorem, right? Why is it Pythagoras Theorem? Because it's trying to help me find effectively this length here. Really wish I could draw a straight line properly. All right, that's way too complicated, don't you think? Well, why would that be helpful to us? Well, this is what I'm saying. That there is called the slant height. If they give me this, on the question, I would always want to use this formula here, which tells me pi r squared, which is the area of the bottom. That's a circle. So there we go. Look, my cone always has a circle on the bottom, plus pi times r times my slant height. Wow. So I'm going to call this S for my slant height. Tell you, I'm serious. If they give you shape number 2, if they give you information number 2 with the slant height and the radius, you just want to smile to the heavens and say thank you very much, because otherwise this formula here, yuck. So here's an example, finding the surface area of the following cone. They did not give me the slant height. Oh, evil. So the first thing I'm going to need to do is write down that surface area is equal to pi times r, brackets r, plus the square root of h squared plus r squared, close bracket. What is my value of my radius? It's 2 centimeters. And what is the value of height? It is 5. So I'm just going to put those numbers in. So pi times 2, brackets 2, plus the square root of 5 squared, plus r squared is 2 squared, close brackets, which equals 2 pi times 2 plus 5 squared is 25 plus 2 squared is 4. Now notice how I'm breaking down the question line by line by line. I'm trying to do bits at a time, which is 2 times pi times 2 plus 25 plus 4 is 29, so it becomes root 29. Now, that is where I'm going to leave it. Your exam undoubtedly, or questions will say to round that or to find an answer correct to 2 decimal places. It is at this point I would put that onto my CAS calculator, I would press equals, and then I would write down exactly what the answer is, rounded to the appropriate number of decimal places, and the question will tell you. Okay, so I chose to do a difficult example there because I think sometimes it helps. Basically doing slant height means you just have this nice simple formula. Same thing with the calculator. Use your calculator. That's what it's there for. Composite solids, almost at the end of this lesson. Yay. Same thing. Composite solids are shapes which are made up of one or more different shapes stuck together. So in this situation, what do we have? We have a square base pyramid. Bow, 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 bow. On top of a cuboid. So because it's stuck on top, I can use different formulas here. I could find the area surface, I could find the total surface area of the cuboid. I could find the total surface area of the square base pyramid and add them together. But if I do that, I've got a major problem. Why? Because there is an overlap. And when there is an overlap, you can't see that surface. And so you have to take it away. So in this situation, if I was going to do it that way, I'd then have to find the area of the base here and I'd have to find the area of the top here and then take them away. Sometimes it's actually better just to say, I'm going to find the area of the front, I'm going to find the area of the back, I'm going to find the area of the side, the area of the side, I'm going to find the area of the base here, and the area of the 4 triangles, and break it up that way. All right, it depends on the question, but whatever you do with composite solids, make sure that where there is an overlap, you take away that overlap from both shapes. That's why I'm taking away 2 lots of the squares here. 1 for the bottom of the triangle because it's never seen, and 1 from the top of the cuboid because it's never seen as well. All right, that, ladies and gentlemen, is the end of surface area of pyramids and cones. Hopefully you've enjoyed that, and hopefully it's made some sense. Look, it's a much shorter lesson than the last 2, so I look forward to seeing you next time.
It's been so great having you watch this video that I'd like to see you again and again and again. Wow, we could make some amazing maths together. So, if you'd like to, and you'd like to be updated as to when I upload new videos, why not subscribe by clicking the button on the right? Otherwise, if you want to click and see another video created for this type of series, then click the video on the left. All right, well, you have an awesome day, and I look forward to see you again.